In this video, we're going to talk about polymers from alkenes, specifically addition polymers, and we'll go through different options of how you make them in the repeating units. So addition polymers are just polymers, which is a long chain, made from monomers, and those monomers are called alkenes. So addition polymerization, where the monomers contain that C double bond C to form those long chains. Those long chains are made of repeating units, and we'll teach you how to recognize those repeating units. And the small molecules that react together are called those monomers. Now again, you're not really going to be asked to recall this or say this in terms of remembering a definition, but you would need to recognize the words that are in a question. So let's have a look at our addition polymers made from the monomer ethene. So what we have here is an ethene molecule. That's your C double bond C. And what happens is the C double bond C breaks. And what happens, and we'll just show you that again. Notice here, 1, 2, 3, 4 bonds. All right, and when I break it, there's still 4 bonds because I've added 2 extra. If I didn't add these 2 extra on the outside, that carbon wouldn't have 4 bonds, and it needs 4 bonds. Okay, so that's really important when you're doing organic chemistry. So if we look here, we now can bond them together because that bond, where is it going? Well, that bond is going to go to this one down here. You see it move up, and see it's bonding to there. So therefore, all of the carbons have the same bonds. And this is 4 repeating units. So the white one, the orange one, blue one, and the green one. Okay, so they're 4 repeating units. Now, it's not so obvious with polyethene what the repeating unit is, okay, if you're looking at just this long chain because it's all the same, but many of them are very different, so you can tell. Now, we can generally do feedstock recycling on this, and this is referred to in another video in more detail, but basically they can break these back down into the alkenes, and they can be used again for something else, and that's one way of doing something called feedstock recycling. Now, as I said, if you look at it, it's quite hard to see the repeating unit here once you take all the colours off. So let's try and do it from first principles. So I've got my definition over here, and all I want to do is draw my monomer going into my polymer. So here we have, and again, if you can do this straight away, then just do it straight away. Don't wait for the video, just do it straight away. So there is my ethene. And often you'll see an N at the front, but don't worry too much about the N. In A levels, they don't really care that much, but it just means lots of is a big number. Right, okay, so we've got that, and we're going to turn it into our repeating unit. Now, we know from the previous one that you can turn it into a long chain. We've got that long chain, okay, but what is the repeating unit within the long chain? So we do it exactly the same as we did it before. You've got 2 bonds here. We're going to break that double bond. So if we break that double bond, and then as a really good tip, especially in your first year of A-levels, just point, and GCSEs, point everything up and point everything down. It's the biggest tip I get. Point everything up from the double bond and everything down. So once you've taken the double bond away, everything up, everything down. Okay. Now, from that point, you then count the number of bonds. 1, 2, 3, and 1, 2, 3 on each side. So we've got 3 on each side. So that's the case. Let's put the extra bonds in so it has 4. Now, if you imagine this repeating unit, boom, 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 and creates the long chain. Now, in A-levels, you'll just get the mark for that. But if you're doing it properly, you would put a nice little square bracket or a normal bracket around it, doesn't matter. And you would put an N there just to say there's lots and lots of these repeating units going through. And if you did lots of repeating units, you just come back to the normal picture that we showed you in the previous slide. But that is how you turn a monomer into a repeating unit. Our next example is going to be polypropene. So remember, when we're naming them, we just put poly in front of the alkene name, the monomer name. So polypropene. So if you can do this already, we're just going to turn it into the repeating unit, and then we're going to draw a section of the polymer as well. So first of all, propene. We need to know what propene is. So I'm going to show you what propene is in terms of, here is your propene. So it's got 3 carbons in it. So 3 carbons in it, prop, 1, 2, 3. And then 4 bonds to each one. So people often make mistakes when it comes to polypropene. It's the one where people just make some simple errors. And we're going to try and show you not to make the simple errors. So if you're thinking about this right now, you might think, right, okay, we need to break the double bond and then add 2 bonds either side. That's where people go wrong. So they'll break the double bond and then put them either side. When I said break the double bond, I mean add bonds to each side of the actual double bond itself. Now, that may not make much sense, but let's do it like this. I need to expose this double bond. So what I'm going to do is going to do my rule that I had at the start, which is I'll draw everything up and everything down. So if that is the case, that's CH3. I can shorten that to CH3 if I want to keep it simple. So take up that space, CH3. Okay, and then I can put my other H there. That's still propene. 1, 2, 3. That's propene, okay? But now I can kind of see what's going on. So I can just go, right, okay, if that's the case, double bond. I'm going to take the double bond, we're going to remove that double bond, and we're going to add, I'm going to draw everything that we had before. Okay, so we've got that. But now we're going to look at it and go, right, okay, how many bonds? 1, 2, 3. Ah, we need a fourth. 1, 2, 3. Ah, we need a fourth, okay. And there is a beautiful repeating unit. Okay, and again, you can put the ends in if you want. You don't have to put the ends in if you don't want. Not at A levels, we're not that bothered. Okay, so if you look at it, there's a perfect one. And this is often the one they get wrong. Okay, so let's then draw this in a slightly different way. And let's draw it as a few repeating units. So what you often see it is like this. And I'm just going to draw 3. Okay, and why don't you see, I'm going to draw 3 repeating units. So why don't you see if you can draw 3 repeating units instead of just watching the video, okay? So if that's the case, you might see 3 repeating units like this. So there's, I'm just put all the bonds in. Again, why don't you draw this instead of just watching me do it? Okay, and then I can just put CH3, there, H, CH3, H. And you can practice drawing 3 sections of something like this because you will be asked to do it in the exam, okay? So I've just drawn 3 sections. And we're going to go through one more example after this as well, so why not do it? All right, so this is the case. We now need to look from here and say, well, how can we recognise what the repeating unit is? So what you need to look at something is repeating. So what is repeating? So I can see that this section here is repeated here, okay, which is repeated here. Okay, so it's repeated there. So that's my repeating unit. And if you then take this repeating unit that's here, it's like this, except for just rotate it around 180 degrees. So literally take that and go zoom. It is exactly the same as that. It's got 3 hydrogens, CH3, okay, and that is 3 units of polypropene, okay? So get used to converting it into its repeating unit, so that's your repeating unit on the right-hand side, okay, and be able to draw a few units, 2, 3, 4, maybe units together, and be able to recognise from those units what is the repeating unit. From these 3 units together, what is the repeating unit? So we're now going to do the second most common example, which is polystyrene. So you can see polystyrene's got this group here. And that group there is called benzene. And you see it's written in skeletal kind of formula with a circle. And you can also draw it with 3 double bonds in it. But there's another video about that if you want to go earlier to see that, if you can't remember that. And you can also see it written in skeletal formula fully. So we've got a partial skeletal formula here and then fully skeletal formula. I'm going to do it in both, just to give you an idea that you can do both, all right? So, and to contrast and compare. So basically what we've got here is we're going to have, for this one, we're going to get rid of this double bond. Okay, and I've got rid of the double bond. And I'm going to point everything up and everything down, just like I've told you previously. So exactly the same. And that's all we're going to do. Okay, point everything up, everything down. I've removed the double bond, that's all I've done. And then I put my extra bonds in either side. And I've got my nice repeating unit of that. Now how could I do it if I was doing it in skeletal formula, which you can. Okay, so I'll do exactly the same thing. And I'll get everything, I can do everything pointing up and down, or I don't have to. And so with this one, it's much easier if you do everything pointing up. With skeletal, it doesn't really matter that much. So I'm just going to draw it like that, but I've taken out, and you can see I've taken out the double bond. You see it's gone. Right, I know I need to add 2 extra bonds here and here. So what I do, and this is the clever, you don't have to do this the entire time. If you don't understand this very well, the best way to do it is to keep doing it exactly the same way as which I've done here. Point everything up, point everything down. But if you understand what's going on, you understand a little bit better, you can see, okay, I've taken the double bond out. If I take the double bond out, there's only going to be 3 bonds to this carbon and 3 bonds to this one, so I need an extra one. So what we do is we draw it as dashed lines. And we can draw it as dashed lines like that. And you might ask, why do we do it as dashed lines? We do it as dashed lines because if we drew it as a straight line, it would be part of the skeletal formula. It would look like another carbon. So we do it with dots, or we do it in dashed lines. But either way, we can do it in skeletal formula, or we can do it in normal formula. And either way is absolutely fine for you. I very much doubt they'll ask you to do it in one type of formula. So just do the one that makes you feel most comfortable. In our final example, we're going to talk about polychloroethene, or polyvinyl chloride for its normal name, which is shortened to PVC. So used for this PVC clothing, used to make double glazing and such and so forth. Now, I wanted to do an example just from this structural formula. So try and draw the repeating unit in skeletal, try and draw it in your normal, just from this, okay? And it's all about counting number of bonds. So what we can do is, right, so we've got C and a H2. So we can draw it in our normal way and go, right, okay, here is our CHs, and then there is our Cl. We've got a H and a Cl here, so there's our H and our Cl. So there it is. Now we could go, and there's our double bond. How do we know there's a double bond? Because there's 4 bonds to each carbon. So 1, 2, 3. Okay, so it's got 3 bonds there. And then that includes the 2 to the hydrogens and the 1 to the carbon. So that's only 3. So that basically means that there must be a double bond here, because that means 2 bonds between here and here. So let's put the double bond in. Okay, so there must be a double 1, 2, 3, 4. So that means basically it must have 4 bonds. And that also means the other one here, 1, 2, 3, 4. Okay, it's got 4 bonds around it. Now if that's the case, we've done this, and all we do is exactly the same thing. And we take the double bond out, we draw everything back in again. Okay, and then we put our extra bond around the outside, and that's it, and then we're done. Okay, and you can notice this if you had multiple units as well, which we'll do in a second. But if we do this skeletal, it'd be even quicker. Okay, so skeletal will just be bang like that, and then there's your chlorine, and then all you do is take it out. There's your chlorine again. You know you've lost a double bond here between here and here, so that means there's only 3 bonds to this one, so I need an extra. I do it with that, or I do it with that. Right, okay, so that's your way of doing it skeletally, or you can do it in the normal way. You can also draw 2 or 3 units. So try and do it yourself. Stop the video, draw 2 or 3 units. All right, so I'm just going to draw 2 just for time purposes, and there you go. I've got 2 carbons, 2 carbons. Okay, I know I've got a chlorine on one of the carbons of each pair, and then I go, there you go, and put all my hydrogens in. Okay, and there you have it. Now if it's a section of a polymer, it's a section leading on to another section, so I have my bonds going out to the rest of the polymer. Okay, and then all I do is look, where's my repeating unit? Well, my repeating unit is the Cl repeats every 2, so basically there's my repeating unit, and there's my repeating unit. Okay, and there you have it. So get used to doing it normally from a structural formula into this kind of displayed formula. Have a go at doing it skeletally, and have a go at doing 2 units or 3 units or 4 units and things like that. These are the kind of different questions that you'll get asked about polymers.